Assalamualaikum and a very good day to Dr. Yusuf and Dr. Razif. This is our assignment for ECH3201 Biochemical Engineering, and we from Group 8 would like to present on downstream polishing. Polishing is the major finishing steps in fermentation product purification. Therefore, this process is separated to two types, which is crystallization and drying. So next slide, I'll pass to the next presenter.
So for crystallization, first of all, you all know what is crystallization. Crystallization is actually a process where solid material is formed from the liquid. This solid material form will have a crystal-like structure, and this process is also a technique for substance purification. Crystallization process has its own characteristic. The feed material should be in liquid or solution above the melting point of a solid phase. Also, dissolved or solid impurities may present and it may remain in the solution, crystallize separately or incorporate into the product crystals. Besides, crystal form is a solid which varies in size. Finally, after the process occurs, waste stream will contain liquid which consists of both residuals, dissolved product and impurities. I'll pass to Hani.
Okay, how crystallization process occur? Okay, there are two, nucleations and also crystal growths. In nucleations, molecule gathers together in cluster in a defined manner. Cluster need to be stable under current experimental conditions to reach the critical cluster size or they will dissolve. It is this point in the crystallization process that define the crystal structure. While in crystal growth, nuclei that have successfully achieved the critical cluster size begin to increase in size. Crystal growth is a dynamic process, with atoms precipitating from solution and becoming redissolved. Supersaturation and supercooling are two of the most common driving forces behind crystal formation. Next, I will pass to Zira.
Next, for the method of crystallization, there are four methods. First, solvent evaporation, easy to set up, requires as stable samples, require a minimum solvent volume of work to work efficiently. Large amount of material required. For the slow cooling, require solvent with boiling point less than 100 degrees Celsius and moderate solute solubility, large amount of material required. For the third method is solvent vapor diffusion, which is it works well with small amounts of material. However, finding two suitable solvents can be challenging. And all out. And lastly is sublimation, not the method of choice for diffraction. Quality crystals typically perform at high temperature, causing crystals to grow quickly. For the advantage of crystallization, there are 5 advantages. First, a high purification can be obtained in a single step, produce a solid phase which may be suitable for direct packaging and sale, operates at a lower temperature with and with lower energy, requires then corresponding distillation separation. Plant can be simple and easy to construct and maintain, and may be more economic than alternative separation processes. And for the disadvantages of the crystallization, the first one is generally only purifies one component. Yield is limited by phase equilibria. Process kinetic are more complex and less well understood than some alternative. Some substances remain with the liquid and liquids need to be purified for further use. For the applications of crystallization is catalyst, dye stuff, detergent, fertilizers, electronic materials, pharmaceutical and food stuff. Next, I will pass to the next presenter.
So for the next downstream processing is drying process. So in most manufacturing processes, drying process is usually the last step and it involves the process of removing water and ice solvent while preserving the product's viability as much as possible. For example, food are exposed to a continuously flowing stream of hot air and that involves simultaneous mass and heat transport. So moisture availability has a great impact on the transfer of heat to microorganisms. Next, so how it works. So drying involves the removal of water as much as possible in the initial stage by using either centrifugation or filter press. It reduces the drying process heating cost by requiring less water to be evaporated. The drying process depends on the goal water content, initial water content, physical stress sensibility, and others. Usually drying starts with mechanical drying with press dryer or centrifugal dryer to remove the initial amount of water. Next, I'll pass to the next person.
Okay, next for the methods of drying, there are a few methods of drying such as vacuum tray dryer, freezing drying, rotary drum dryer, and more. Okay, for vacuum tray dryer, it was by removing the moisture through a vacuum crate. So this method of drying is particularly useful for the product that are sensitive to heating. So in the context of bioprocess, the drying of enzyme could be dried by using this method as heating could cause the denaturing of the enzyme. Okay, so for the freeze drying, it typically involves four stages, which is the pre-treatment, freezing, primary drying, and secondary drying. Okay, next for the pneumatic conveyor dryer, pneumatic drying requires a reasonable solid fit as particles. So heated air conveys the particle and will remove the moisture. So the advantage of this pneumatic drying that is very mechanically strong, reasonably fast process, and at the end of the content of water is low. And disadvantage of pneumatic drying conveyor dryer is the it requires somehow low moisture content to start and is usable for the relatively solid material. So next I pass to the next presenter.
Okay, thank you, Iza. The advantages of drying is it inhibits the growth of bacteria, lightweight and easy to carry, increase the lifespan, and have high quality product. Next slide, please. The disadvantages is it changed the texture and appearance. It costs a long time, and it causes a loss of vitamins. Next slide. So the application of drying is it can be made into antibiotics, hormones, fragrance, and space foods. That's all from us. Thank you.